Friends in Choueifat school, this is Wael Bashwari, math and physics teacher. In this video, I'm going to solve this course practice test for the periodic 4.3. Course practice 4.3. Question number 1: for a charged particle of charge Q to move between the terminals of a 12-volt battery, it has to release 24 joules of energy. What is the charge of the particle? Choose the answer. So here you have to use the formula W equal QV. Write it in your notebook because this formula is very important. You're going to use it through the whole test. So W is 24, that's the energy, equal to Q, that's the charge, quantity of charge, times the voltage. We don't know the voltage. So the voltage will be, the quantity of charge will be 24 divided by 12, and that will be 2 coulomb. So here you have to choose 2 coulomb from the list. So here you have to choose 2 coulomb. Question number 2. During 1 hour, 2700 coulomb of charge flow through a battery as shown in the diagram. Fill in the blank. The average current through the battery to 2 significant figures is. So here you are given the quantity of charge and you are given the time. The time is 1 hour and 1 hour is 3600 seconds. Time must be in seconds. So we want to find the current. Q is equal to IT, or you can say I, if you rearrange the formula, I equals to Q over T. So Q is 2700 divided by time, which is 3600. Then use your calculator to find the answer. 0.75. We want the answer to 2 significant figures, so we keep it 0.75. Question number 3. Two metaspheres A and B are initially neutral. Electrons are taken from sphere A and transferred to sphere B. The amount of charge transferred is 0.64. Fill in the blank. When the spheres are connected with a thin metal wire, they become electrically neutral. During 2 seconds, the average current flowing through the wire during the given time interval in to 2 decimal places. So here you are given the time T, which is 2 seconds. You are given the charge Q, which is 0.64 coulomb. Now the current is required. So the current is equal to quantity of charge divided by time. So you have to divide 0.64 by 2, and that will be 0.32 ampere. Question B. During the time interval considered in part A, the wire becomes hot. What energy conversion takes place? Choose the correct answer. Now, if you go to the list, here you have electric potential energy to heat. Next question. 2 metal spheres A and B are initially neutral. 80 coulombs of charge are taken from A and transferred to B to create potential difference of 3. The amount of work done. Work done or energy, same formula. So work is equal to QV. Q is given as 80 and voltage is 3. So 240 joule. That is the answer. Question number 5 now. The potential difference between 2 points V when the charge of Q falls from one point to another, an amount of energy W is released. So here you have to use the same formula. W is equal to QV. For the first one, you multiply QV. This is, remember, this is Q and this is V and this is W. So 1 times 8 is 8. Here you have 8. 2 times what number I get? 6, 3. 2 times what number I get? 18, 3. And that is the answer for question number 5. Now for question number 6. Select the picture illustrating the case where electric potential energy of the system increases. Electric potential energy increases when the potential difference between the two spheres increases. And this happens when you take positive charge, for example, from this sphere to give it to this sphere. Like this, the positive on the right will increase and the negative on the left will increase. So the electric potential difference will increase, so energy will increase. Also, when you take negative from this to give it, no, 1 second, let's see. When you take negative from this to give it to this, like this also, the negative on the right hand will increase, the positive on the left will increase, like this energy will increase. Next question, consider one of the correct diagrams selected in part A. The potential difference between the spheres is 7, so this is V, and the quantity of charge is 2. The amount of work, what is it? So as we said, amount of work is equal to QV. Amount of work is QV. So work is equal to times 7, which is 14. So here we have to write 14. When the spheres are connected by a conductor, the same charge Q spontaneously falls from one sphere to another during 2 seconds. The current in the conductor is what? The current is equal to Q over time. Quantity of charge divided by time. Quantity of a charge here is 2 and the time is 2. So the answer is 1 second. So the answer is 1 ampere. So here you have to write 1 ampere. Question number 7. Here you have another formula, which is charge, time, and current. Q is equal to IT. Remember, this is I, the current, this is T, the time, this is quantity of charge, Q. So Q is equal to IT. We have to multiply current times time to get Q. So what number here multiplied by 4 to get to 0.5? What number here times 4 to get 4? It's 1. Now 2.5 times 2, remember, this 2.5 must be here and this 2 must be here. So 2.5 times 2 is 5. So here you have 5. Question number 8 now. A device powered 12 volts power supply. During 1 minute, 6 coulomb of charge moves through the device. The current that flows through the device is. So here we have got to use another formula. Power is equal to VI. The power is given here. The voltage is given. And we want current. And also we have the formula Q is equal to IT. So quantity of charge here is 6. I, we don't have it. The time is 1 minute, 60 seconds. This means I would be 6 divided by 60, and this is 0.1. 1 over 10, 0.1. So here you have 0.1 ampere. The energy converted in the device during the given time. Energy is power times time also. So let's see what you have to use. We don't need this formula, so let's use W is equal to QV. W is the energy. So W is equal to Q, which is 6, times V, which is 12. So 72 joule. So here you have to write 72. Question number 9 now. A crane lifts uniformly a mass of 150 kilograms through a height of 20 meters. Assume G to be 10 meters per second squared. The motor of the crane is powered by a power supply of the following specifications. You are given the voltage 40 and the current is 5 amps. Gravitational potential energy supplied by the power supply is GPE. GPE is equal to mgh. The mass is given as 150 times G is 10 times the height, which is 20. Now if you calculate, 2 times 15 is 30, and you have 1, 2, 3 zeros, 30,000. joule. In kilojoule, they want the answer here in kilojoule. Divide by 1000, so you get 30 kilojoule. Question B, the power of the electric motor is. Now the power is equal to VI, the voltage is given as 40, the current is 5. 5 times 40 is 200 watts. So that's the answer for B. The time to lift the load. Now also we have got another formula, which is power is equal to work over time. The power, as we said, is 200. So we write 200 is equal to, the work is 30,000, that's the energy, divided by time, we don't know the time. So here you can divide 30,000 by 200 to get the time. So let's solve it up here. Time will be 30,000 divided by 200. Cancel the zeros. 300 divided by 2 is 150 seconds. So here you have to write 150 seconds. While the load is lifted, the power supply runs how many coulombs through the motor? Quantity of charge is equal to IT. So we need to multiply the current, which is 5, times the time that we got, which is 150. Like this, we solved all the questions. Now, question number 10. Here you are given power, we want energy, we want current, we want charge. In this question, we have to find energy here. So energy is equal to W is equal to QV, and here you have also power. So I have to use another formula. Energy, let's write it here. Energy is equal to power times time. So the power here is given as 1100 watt, and the time is 1.50 minutes, but you have to convert it into seconds, so you multiply by 60. Now you calculate this, you get 99,000 joule, and if you convert it into kilojoule, you get 99. So here you have 99 kilojoule. Now for calculating the current you calculated from the formula of the power. So for this question here, power is equal to VI. Remember this formula also. The power is 1100. So here you have 1100 is equal, the voltage is 220 times I, we don't know it. To find I, we divide 1100 by 220. So you get 0.5. One second, let's see. 1100 divided by 220. That's the voltage. So cancel 0 and 0, and then divide 110 divided by 22. You get 5. So here you have 5 ampere. To calculate now the charge, as we said before, Q is equal to IT. We have the current, as we found here, 5. And we have the time. The time is 1.5 times 60 to convert it to seconds. So 1.5 times 60. Like this, we solved the first part. I will leave the second part for you to solve it. Question number 11. The filament lamp is labeled 120 volts, 60 watts. 1 watt is equivalent to 1 joule per 1 second. The efficiency of the lamp is 0.08, which means 8% of the supplied energy is converted into light while the rest is lost as heat. Fill in the blanks. The energy consumed by the lamp during an hour is what kilojoule? So to find the energy, we said before, energy is equal to power times time. So here you are given the power of the lamp is 60 times the time, 1 hour, 3600. Like this, you got 216,000 and in kilojoule 216. You have to divide by 1000. For question B now, the current that flows through the lamp is what? The power is equal to VI, so power is equal to VI. Now I is equal to power divided by voltage, and the power is 60, so 60 divided by voltage, which is 120, and this is 0.5, so the answer here is 0.5. The charge that flows through the lamp during 1 hour, here we say Q is equal to IT. So I is the current, which is 0.5. We calculated this in the previous question. And the time is 1 hour, which is 3,600 seconds. And we get 1800 coulomb. In kilocoulomb, we divide by 1000 and we write it 1.8 here. The amount of light energy released by the lamp during 1 hour, here you have to use the efficiency, which is 8%, and multiply the efficiency, which is 0.08, times the whole energy, which is what we got in question A, 216,000. So we get 17,280 joule. In kilojoule, we divide by 1000, we get 17.28. Nearest whole number is 17, so 17. Here you write 17. Question number 12 now. At certain conditions, lightning occurs when the potential difference between a cloud and Earth surface is 300 megavolt. Mega means million here. During 2 milliseconds, milli means 10 to the power of minus 3. A charge of 100 coulomb passes between the cloud and the surface. The lightning produces a current of what amount? So here to find the current, we say Q is equal to IT. So the current I is equal to quantity of charge, which is 100 coulomb divided by the time, which is 2 milliseconds. 2 times 10 to the power of minus 3. So now we calculate this. So here you get 50,000, which means 5 times 10 to the power of 4. The amount of electric potential energy spent in the lightning, so W is equal to QT, QV. W is equal to QV. Quantity of charge is 100 times the voltage is 300 million. So 300 times 10 to the power of 6. That means 300 million. So if you multiply these, you get 3 times 10 to the power of 4. So here you have to write 3. Question number 13. A laptop battery supplies 12 volts and 4.5 amperes. The laptop works 3 hours. Before the battery runs out, the charge that passes through the laptop during the given time interval is what? So here you have to do quantity of charge is equal to IT. The current is given as 4.5. The time is 3 hours. So 3 multiplied by 3,600. Then you choose the answer. The amount of energy that the battery can store, W is equal to QV. So Q is what we got here. Let's calculate it. That was 48,600. So 48,600 times the voltage, which is 12. Multiply them and get the answer. Question 14. A photo camera is equipped with a flashlight which helps shoot pictures in low light conditions. The flashlight stores 4.2 joules of energy and the flash occurs during 0.50 seconds at 12 volts. The charge passing through the lamp is Q is equal to IT. So you multiply the current, which is here. Are we given the current? Let's see. So we don't have the current. They asked about the current in the second question, part B. So let's use this formula for part B. Now for part A, we can see that the W is equal to QV. Now W is the energy in joules, 4.2. The charge, we don't have it. The voltage is 12. So Q is equal to 4.2 divided by 12. So what is 4.2 divided by 12? 0.35. So here we write 0.35. Now the current that passes through the lamp, for the current we have to use this formula as we said. So I is equal to Q over T. So I will be Q that we got here, 0.35 coulomb divided by time. The time is given in the question 0.50 seconds, 0.50. So now you divide 0.35 divide by 0.50, 0.7 amps, 0.7 amps, and that's the question. That's the answer for the question. Now, question number 15 is the last question. During 1 hour of charge, 2700 coulombs of charge flow through a battery. The average current through the battery into 2 decimal places, what is it? Okay, here during 1 hour means the time given to us as 3600 seconds, and quantity of charge is given to us as 2700 coulomb. So now Q is equal to IT. This means I is equal to Q over T, and Q is 2700 divided by time, which is 3600, and this is 0.75 ampere. That's the end of the test. Thank you very much indeed for watching. Don't forget to subscribe to my channel. Hopefully you understood everything.